So hello friends, in the class third unit for DSP finite impulse response filter oda Fourier series method discuss பண்ண போறோம். So Fourier series method problematic எப்படி solve பண்ணலாம், how will you compute a FIR filter with the help of Fourier series method, இதெல்லாத்தையும் இந்த யூனிட்ல பார்க்கலாம். சரியா? So our problem is, so இதான் நம்மளோட problem. A low pass filter is required to be designed with the desired frequency response hd of omega is equal to e power minus j 2 omega for a limit minus 0.25 pi to 0.25 pi, otherwise it will be 0, where capital N equal to 5 using Fourier series method. Okay, so this is the Fourier series method oda problem. Here we have to use a filter name as low pass filter. Okay, so how will you compute? Step number 1 is draw a graph. Okay, so in the problem thoda எப்பவுமே இந்த ப்ராப்ளத்தோட first step என்னதான் இருக்கும்னா draw a graph தான். Okay, so draw a graph. A given filter is a low pass filter, so the graph becomes low pass filter oda basic graph இப்படி தான் இருக்கும். சரியா? low pass filter oda graphல x axis contain omega and y axis contain hd of omega. Here our problem contain a limit is minus 0.25 pi to 0.25 pi. So I write 0.25 pi and minus 0.25 pi. Okay, then step number 2 is to find alpha. So for low pass filter, for calculating alpha, the formula is n minus 1 divided by 2. So here we know the capital N value. Our capital N value becomes n equal to 5. So I substitute 5 minus 1 divided by 2 is equal to 4 by 2. I will get alpha equal to 2. This is step number 2. Okay. Then step number 3. Our step number 3 is to find hd of n. Okay, so for calculating hd of n, this is the basic formula: 1 by 2 pi integral minus pi to pi hd of e power j omega into e power j omega n. Okay, so here this problem contain a limit is vary. The problem limit is minus 0.25 pi to 0.25 pi. So I substitute 0.25 I consider, that is equal to pi by 4. Okay, so pi by 4 minus pi by 4 to pi by 4. Then our input is e power minus j 2 omega. So e power minus j 2 pi omega. This is our given input. Then remaining parts e power j omega n into d omega. Okay, then here for in the power j and omega is common, so I take it outside. So e power j omega, then remaining terms are n and 1 minus 2. So I write n minus 2. Okay, so then next one is to integrate this. So for integration, 1 by 2 pi, then e power j omega n minus 2. For integrating this, I will get e power j omega n minus 2 divided by the constant terms are in the denominator j into n minus 2. Then limit pi by 4 and minus pi by 4. So I substitute my limits. So I will get here 1 by 2 pi and this part is constant. So 1 by 2 pi j n minus 2. Here my variable is omega, right? So I substitute omega is equal to pi by 4 and minus pi by 4. So e power j, our upper limit is pi by 4, so pi by 4 into n minus 2. Then one more minus, then lower limit e power minus j pi by 4 into n minus 2. Okay, so this is in the format of e power j theta minus e power minus j theta. So already we have to know the formula for e power j theta and e power j theta minus e power minus j theta, that is equal to 2j sin theta. So this step becomes 2j sin theta is pi by 4 n minus 2. Okay, so I write 2j sin, our theta value is this. So here numerator contain 2j and denominator contain 2j. So these two terms are cancelled to each other. Then finally I get 1 divided by pi n minus 2 into sine pi by 4 n minus 2. Okay. So listen carefully here. So this is the final answer for hd of n. Okay. So here I substitute n equal to 2 means plus 2 means here 2 minus 2 is equal to 0. So this term fully becomes 0. Right. So sine 0 is equal to 0. So finally our hd of 2 value is 0. Okay. So hd of 2 oda value 0 ஆக வரவே கூடாது. சரியா? So வராம இருக்கிறதுக்காக தான் என்ன பண்ண போறோம்னா hd of 2 க்கு நம்ம இந்த ஃபார்முலாவை சூஸ் பண்ண போறது கிடையாது. அதுக்காக தான் நம்மளோட பேசிக் ஸ்டெப்ல நம்மளோட previous வீடியோல பாத்தீங்கன்னா தெரியும் லோ பாஸ் ஃபில்டரோட some characteristics அதல கொடுத்திருந்தாங்க. அதுல ஒரு டேபிள் கொடுத்திருந்தாங்க. அந்த டேபிள்ல some conditions கொடுத்திருந்தாங்க. சரி? அந்த கண்டிஷனை நம்ம அப்ளை பண்ண போறோம். சோ அதனால தான் இதுல என்ன எழுதி இருக்காங்கன்னா for n is not equal to 2. So here we have to substitute n equal to 2 means what happened? The hd of 2 becomes 0. Okay. So அந்த மாதிரி வரக்கூடாது. So அதுக்காக நம்ம என்ன பண்ண போறோம் அப்படின்னா லோ பாஸ் ஃபில்டரோட டேபிள் ஃபார்மேட்ல இருக்கக்கூடிய சம் ஃபார்முலாவை ஸ்டாண்டர்டா எடுக்க போறோம். ஓகே. So இதுதான் நம்மளோட டேபிள் வேல்யூ. அந்த டேபிளை நான் அப்படியே இதில் எழுதியிருக்கேன். For low pass filter hd of n equal to omega c divided by pi for n equal to alpha. So here alpha value is 2, right? So for n equal to 2 means we have to choose this formula. Otherwise we go for this formula. Okay, this is our low pass filter condition. So I substitute n equal to 2 means I use this formula omega c divided by pi. So omega c is nothing but our cutoff frequency limit pi by 4 divided by pi I get 1 by 4. So for hd of 2 means my answer is 1 by 4. Otherwise for calculating hd of 0, 1, 2, 3, 1, 3, 4, 5 means I choose the hd of n formula, this formula. Okay. So hd of 0, first I calculate hd of 0. So I choose my own formula, this formula. So here hd of 0 means I substitute n equal to 0 for this formula. Okay, so I will get sine pi by 4 n equal to 0, right? So 0 minus 2 divided by pi into 0 minus 2. So I will get sine pi by 4 into minus 2 divided by minus 2 by 2 pi. So substitute simplify this, I will get 1 by 2 pi using calculator to solve this and get the answer 1 by 2 pi. Similarly to calculate what is hd of 1. Okay, so for hd of 1 I will get 1 by root of 2 pi. Then hd of 2. So hd of 2 means I choose the alternate formula. Then only I calculate hd of 2 answer. So my answer is 1 by 4, right? So hd of 2 is 1 by 4. This will be already found. Then hd of 3 is as usual formula, this formulas. So I will get 1 by root 2 pi. Okay. Similarly I calculate hd of 4. I will get 1 by 2 pi. Okay. This is step number 3. So step number 3 is to calculate hd of n for various n values. Then step number 4, to find h of n. Okay, so previous step we have to calculate what is hd of n. This step we have to calculate what is h of n. So one more condition for low pass filter here, hd of n is defaultly equal to h of n. So h of n is equal to hd of n. So already we found the hd of values. So this value is equal to h of n. So h of hd of 0 will so we have to calculate it. So the answer is 1 by 2 pi. So the hd of 0 value is equal to h of 0. Similarly hd of 1 is equal to h of 1. Similarly hd of 2 is equal to h of 2. hd of 3 is equal to h of 3. hd of 4 equal to h of 4. This is step number 4. Okay. Then step number 5 to find h of z. So for calculating h of z, another one formula for calculation of h of z. h of z is equal to h of alpha plus summation n tends to 0 to n minus 1 h of n z power n. Okay. For low pass filter, h of z formula is this. So Next one, h of z is equal to, here alpha is equal to 2. No, so h of 2 plus summation n tends to 0. N minus 1 means our n value is 5. So 5 minus 1 is equal to 4 into h of n z power n. Okay. So I expand the summation. So I will get h of 2 plus h of 0 into z power 0 plus h of 1 into z power 1. Then h of 2 into, sorry, here h of 2 term is common. அது already வெளியே இருக்கு. So அதனால h of 2 ஓட term முன்னாடி வரதுக்கு தேவையில்லை. சரியா? So அதனால தான் h of 2 வந்து நம்ம consider பண்ணல. Then h of 3, h of 4. Okay. So here we know the value of h of 2, h of 0, h of 1, h of 3 and h of 4 for the previous one. So இதில இருந்து நமக்கு எல்லா வேல்யூமே தெரியும். I just substitute all this value. I will get 1 by 4, 1 by 2 pi, 1 by root of 2 pi into z power 1, 1 by root of 2 pi into z power 3 and 1 by 2 pi into z power 4. So finally, for a similar steps, I take a constant term in outside. So I will get 1 by 2 pi, here 1 by 2 pi, here also 1 by 2 pi. So I take 1 by 2 pi outside. So I will get 1 by 2 pi into 1 plus z power 4. Similarly, here 1 by root of 2 pi is common for this term and this term. So I will get in outside. So 1 by 2 pi is outside. I will get z power 1 plus z power 3. Okay, this is h of z. Then step number 6 is find h dash of z. So for using h of z, we have to calculate this one. Okay. So h of z contain one more formula, z power minus n minus 1 divided by 2 into h of z. Here we know the h of z answer. Just substitute these values here. So I will get z power minus n minus 1 means here 4 divided by 2 means 2. So z power minus 2 into h of z. So z power 2 into h of z is our previous step answer. So I write this here. Then to multiply h power minus 2. h power minus 2 ஆல இந்த bracket ஃபுல்லாத்தையும் multiply பண்ணும்போது, so I will get 1 by 4 into z power minus 2. Similarly, I will get this. Okay. So finally, here 1 by 4 into z power minus 2 plus 1 by 2 pi z power minus 2 plus 1 by 2 pi, here z power 4 and z power minus 2. So here I will get z power 2. 4 minus 2 is 2, right? So z power 2. Here also z power 1 and z power minus 2, I will get z power minus 1. Then here z power 3 and z power minus 2, I will get z power 1, right? So finally we get this format, 1 by 4 z power minus 2. For a common steps, we have to take a common constant as outside. So finally 1 by 2 pi into z power minus 2, 1 by root of 2 pi into this term. So for considering this is the final answer for h dash of z. இதில் இருந்து நீங்கள் என்ன பண்ணணும்னா h dash of 0, அதாவது small h dash of 0னா என்ன, 1னா என்ன, 2னா என்ன அப்படிங்கிறத ரைட் பண்ணணும். ஓகே. ஸோ ஹியர் இங்கே பார்த்தீங்கன்னா தெரியும் z பவர் minus 2 அப்படிங்கக்கூடிய ஒரு டேர்ம் ஃபஸ்ட்டு டேர்மாக இருக்குது. ஸோ h dash of 2 ஓட ஆன்சர் என்னவாக இருக்கும்னா இந்த ஆன்சராக இருக்கும், 1 by 4. ஓகே. லோ பாஸ் ஃபில்டரோட கிராஃப் நீங்கள் பார்த்தீங்கன்னா தெரியும், 0ஓட 0 அப்புறம் ப்ளஸ் ஒரு மைனஸ், அந்த கிராஃபை பார்த்தீங்கன்னா இந்த மாதிரி வரும், இந்த மாதிரி இருக்கும். சரியா? ஸோ அதனால் நம்ம என்ன பண்ண போகிறோம்னா, இப்போ இந்த ஃபஸ்ட்டு டேர்ம் வந்து மாறவே செய்யாது, z பவர் 2 minus 2ன்னு இருக்கிறதுனால 1 by 4 வந்து h dash of 2ஓட ஆன்சராக ரெக்கவர் ஆயிரும். தென் 1 by 2 பைங்கிறது எதில் வரும்னா 0, அதாவது இந்த பாசிட்டிவ் சைடு நம்ம எடுத்தாச்சு h dash of 2ங்கிறது, தென் ஒரு 0 வேல்யூ வரணும். ஸோ இந்த 1 by 2 பைங்கிறது என்ன, 0, h dash of 0. ஆஸ் யூஷுவல் 0 வந்தாச்சு, இந்த சைடு வந்தாச்சு. ஸோ இந்த சைடு என்னவா இருக்கும்னா 2ஓட வேல்யூவாக இருக்கும். சரியா? ஸோ இது 0, இது வந்து 2, இது வந்து 1. ஸோ h dash of 0 is equal to 1 by 2 pi, h dash of 1 is equal to 1 by root of 2 pi, h dash of 2 is equal to 1 by 4. This is step number 6. Then step number 7. Find the magnitude of h of z. So here also one more formula, h of omega is equal to h of n minus 1 divided by 2 plus 2 into summation n tends to 0 to n minus 3 divided by 2 into h of n into cos omega n minus 1 divided by 2. Okay. So here h of n minus 1 divided by 2 means 2 plus 2 into n equal to 0 to n minus 3. So 5 minus 3 is equal to 5 minus 3 is equal to 2. 2 divided by 2 is 1, right? So n equal to 0 to 1, h of n into cos omega n minus. Here 5 minus 1 is 4. 4 by 2 is equal to 2. Okay. Then expand the summation. So finally h of 2 means, already we have to found this answer. So h of 2 means 1 by 4 plus 2 into h of 0, h of omega into, here 0 substitute பண்ணும்போது minus 2 வரும். Then summation expand பண்ணும்போது next term 1. So h of 1 into cos omega into minus 1. So இதெல்லாம் நமக்கு h of 0 na என்னன்னு தெரியும், h of 1 na என்னன்னு தெரியும். Just substitute all these items. So finally we get h of omega equal to this. Okay. So h of omega is equal to this means modulus of h of omega is equal to 20 log of h of omega. Okay. So modulus of h of omega calculate பண்றதுக்கு என்ன பண்ணணும்னா 20 log into இந்த final answer போட்டிங்கன்னா உங்களுக்கு modulus of h of omega இருக்கும். h of omega எதுக்காக modulus calculate பண்றோம்னா for using further graph plot பண்றதுக்காக. Okay. So இதுல நம்ம graph plot பண்ண போறது இல்ல. Suppose graph plot பண்றது மாதிரி இருந்துச்சுன்னா நம்ம இந்த ஸ்டெப்ல போட்டு h of omega calculate பண்ண அப்புறம் we have to use this degree values to find a graph versus omega and h of omega. Okay. So this is the formula for procedure for calculating Fourier series method for computing FIR filter designing. Okay. Thank you.